A brief history of space. In the 2nd century BC, the Greek astronomer Eratosthenes used the sun to measure around Earth. His estimate of Earth being 39,690 km was just 340 km off. In the 1st century AD, Claudius Ptolemy set up the Ptolemaic system where the sun, stars and other planets revolved round the earth. In the 16th century, Polish astronomer Nicolaus Copernicus invented a new model with earth revolving round the sun. In the 17th century, Johannes Kepler deepened the Copernican revolution by showing planets traveled the sun in elliptical orbits. In 17th century, the Italian scientist Galileo Galilei improved existing optical telescopes, using which he discovered Saturn's ring and the 4 moons of Jupiter, which were later named the Galilean moons. In 18th century, English astronomer Isaac Newton discovered gravity inspired by an apple falling from a tree, calculating Newton's laws of motion as well. In the 20th century, British astronomer Stephen Hawking showed the universe was boundless, quite like human curiosity, proven by Hawking, who suffered from motor neuron disease but who imagined all of space from his wheelchair. Research Encyclopedia Britannica, NASA, Scientific American, Nature, Space, National Geographic. The times of our universe. Times evoke. The launch of NASA's James Webb Space Telescope JWST marks a milestone in the journey of our universe. The JWST is an observatory orbiting the Sun, seeking the first galaxies that formed in the universe, built, as the BBC reports, over 30 years and costing $10 billion. The JWST is a huge breakthrough using infrared astronomy, which lets it capture light at incredibly distant wavelengths, even seeing our star systems formed just after the Big Bang, the beginning of time, over 13 billion years ago. These systems, which still exist at the very edges of the universe, have been captured in stunning detail. The JWST showing us astonishing cosmic cliffs, shining nebulae and resplendent plumes of interstellar gas. This exploration is crucial for humanity, for it also emphasizes how unique our lives are. We ourselves are composed of stardust. The first stars to form after the Big Bang were 50 times larger than our sun. As is burned fast, nucleosynthesis, the making of elements, began with them. When these stars became supernovas, they expelled these elements, which form new stars and eventually of our bodies too. Every element in our beings, heavier than iron, traveled through time to create us. No wonder Joni Mitchell, the iconic musician, sang in Woodstock, "We are stardust, we are golden." But Mitchell's haunting song also emphasized, "And we have got to get ourselves back to the garden." The JWST underscores this too. Earth is still the only place with life, which began in its waters 3.8 billion years ago. Earth's atmosphere, 78% oxygen, 78% nitrogen, 21% oxygen, 1% other gases like CO2, also shields us from radiation and more moderates of our climate. But for fossil fuel-driven emissions have now caused the Anthropocene, which were literally changing this atmosphere, increasing gases which heat Earth, may manifest in climate change if uncorrected. This will alter water, warmth, and life itself. Yet, as times evolve, global experts emphasize Earth's rare conditions are part of an enormous universal stage where we, creatures of this celestial science and divine comedy, can play a positive part. Joint times evoke in celebrating this celestial story seen through the James Welsh and our own minds. The JWST images can help us cherish Earth's present. Rahul Kannan is a fellow of Harvard University's Institute for Theory and Computation. He tells Times Evoke about how the JWST spotlights Earth. I work mainly on the formation and evolution of galaxies over cosmic time. Galaxies are huge collections of stars, dust and gas which are gravitating themselves and which come in different shapes, sizes and properties. Using computer simulations, I explore how such galaxies form. From my perspective, with the James Webb technology, the most amazing thing is that you can see galaxies which formed 11 to 13 billion years ago. You were therefore starting to see the very beginning structures of the universe itself. This kind of travel through time, which helps us understand the evolution of space, is extremely exciting. With its infrared technology, this telescope has gone farther back in the time than we have ever seen before. The light from these earthly galaxies gets stretched due to the expansion of the universe. Even optical and ultraviolet light get stretched into infrared. Now, because James Webb is very sensitive in this range, we can see galaxies that are extremely far away from earlier and farther back in time. Also, for the first time, we are able to get high resolution images of these galaxies, which tell us how many stars are being formed, the size and stellar mass of these galaxies, the amount of gas and dust therein, etc. I use computer simulations to make predictions for these properties, but we can now match these with JWST data and evaluate how good our simulations of the early universe are. For many people, studying space can seem like a remote exercise distant from everyday life. However, for many, it evokes deep curiosity. If you simply look at the night sky, you see so many different stars. With a small telescope, you can see nebulae and other cosmic phenomena. The question astronomy has always sought to answer is, what exactly is out there? Where do we come from? Our own planetary system is the solar system located in the Milky Way galaxy. Using such space data, we can understand how the Milky Way and its planets and life itself formed. We need to understand how we got here in the first place, and these are interconnected questions in that exploration. Astronomical images like these also help us cherish our present and hopefully save our future. Once you start to understand just how vast the universe is, with so many different galaxies, planets, stars, you appreciate that we human beings are not the center of everything. We are just one small species in the one corner of one average galaxy. Yet Earth is also very precious resource, the only planet which is known to have life. Preserving this resource to maintain life is extremely important. Seeing these images gives us two different Understanding simultaneously, we get a sense of Earth's smallness and its insignificance, as well as its utter rarity. This gives us a very different view of our existence. Suddenly, small, short-term things don't really matter as much. These images help us understand that the big things we should actually invest our energies in are solving challenges like climate change, which is now impacting Earth itself. Light year is the distance light travels in 1 Earth year. 1 light year is 9 trillion kilometers, with light traveling